Okay, the project this month is going to be to find the area of some geographic thing that's of interest to you. You might find the area of your whole state. You could find the area of a lake, the area of a piece of property, whatever. I'm going to actually run through the project myself using a lake in California called Mono Lake, which has a lot of interest in terms of the environment. And the issues with regard to amount of water in the lake, and so finding the area is important for monitoring this. So that's actually an example of why somebody might want to find the area of something like this. And so I've typed in Mono Lake, California, and if we zoom in, this is Google Earth, if I didn't mention that already. And what I want to do is, I'm going to take off the target here and so forth. What I'm going to do is find the area of this, and then you can follow the same kinds of procedures. And I'm going to find the area a number of different ways. And the first thing I'm going to do right off the bat is take a measurement that is so crude you might be a little amazed. I'm just going to treat this like a rectangle and just take length times width, because I want to get a ballpark measurement that's going to be in the right general general size. Even though it's not going to be correct in detail, it'll give me the right overall picture here. The problem is if you do a method that's very complicated and has lots of steps to it and so forth, you're going to come up with a number in the end, but then you're going to wonder, can I really believe that number, or might I have made a mistake? And so it's important to get a rough estimate to compare it to. And so what I'm going to do here is I'm going to use this ruler tool right up here at the top. And let's bring it in. It says ruler, and you can take a line or a path. We're going to do a line, and you can set the units for anything you want. I'm going to use miles. I'm going to convert it to feet and acres later. And I'm just going to put that out of the way a little bit. First thing I want to do is figure out a rectangle that's about the same area, that looks about the same area as the lake. So I'm going to make one that's maybe, I'm going to cut off this part at the end because that's sort of small. So say if I go from about here over to about here, 8.86. Let's just say there it is, 9. So we have 9 miles wide, and let's say about from here down to, that's 8.4. There's 8. Okay, around 9 times 8. Okay, so the area of a rectangle is length times width, and so if we have about 72 square miles, we're not going to be too far off. That's a good one to write down and use that as a comparison to answers you get later to check to see if they're in the right zone. If you get something that's like 500 square miles at a later time, you know you made a real big error. Or if you said 5 square miles, you made a really big error. But if you're up in the range of 9 times 8 is 72, if you're anywhere from 50 to 100 square miles, that's probably a pretty good measurement. Okay. Next thing I want to do is I'm going to capture an image of this so I can import it into another tool, Geogebra, which we used last month and we're going to use many times again. So let's clear this, and I'm going to put a line here. It doesn't matter what length as long as I know what it is. It'd be nice if it's a nice round number. Here's 5 miles roughly, 5.01, 4.99, 5.01. Well, within a pixel, that's 5 miles. I'm just going to drop that there. And so this is something I'm going to capture. I'm going to move this out of the picture a little bit. I'm going to capture this when I do the screen capture. And so that'll show, and we can use that when we're in Geogebra. We can use that as a calibration to scale our method. Okay, that's an important step. You have to know how big your picture is, or it doesn't do you much good. Okay, on your screen there's something called print screen, PRTSC on my computer. It's abbreviated different ways. Just click that button and it saves it into the clipboard. Now I'm going to close down Google Earth and bring up, I'm going to use the GIMP, which is an open source photo manipulation program. I'm using tools that you may not have heard of, but these are ones that are powerful, good tools, and they're free. So you might have Photoshop, or you might have some other image program that you like. Use them if you like, but if you don't have one already, download the GIMP. Okay, if I do Control V, or if I go up here that says Edit and Paste, notice it says Control V right here. Okay, so there is our image. In fact, it's the image of my whole screen with all these folders and everything showing. I'm just going to do a box around. I'm using the little outlining selection tool. I'm going to do a box that captures the lake, and not a lot more. Okay, that should be good enough. And then I go up here that says Image and Crop to Selection. So there's my lake, and I'm going to save that image to my desktop. So I say File, Save As, and let's see. Here's my desktop, and I'm just going to call it, I think I already have an earlier version of this. There's Mono. I'm going to save it over that one. Okay. And save. Okay. So now I'm going to bring up Geogebra. I'm using Geogebra version 4. And up in the toolkits, this one has a pull-down menu here. It says Insert Image. There it says Mono, Open. All right. And let's see what I have. I'm going to move this around. Let's shrink this a little bit. In fact, I'm going to move it so you can see more of what we're dealing with here. This is the drag thing, and it looks like it goes over here to about 12. I can actually change the scale a little bit. I'd like for it to fit between 0 and 10. So I'm changing my numbers now. Notice it's up from about 0.5, and over here is just a little bit less than 10. I'm going to do that just so the numbers come out easy for the tricks I'm going to use in a few minutes. Okay, one thing I'm going to do here is make this image part of the background. And so I right click on it and say Object Properties and click Background Image. The reason is I want to be able to draw things on top of it, and so if the image is sitting on top of the drawings, you won't see the lines. So now the image is in the background and I can draw anything over it. Okay, so let's now measure the length of this line. I'm going to put a line segment right on top of this line. And let's see, come right over to here. There. And this has length that's outside your view. Let me move this over for a second. Over here in the algebra view, it says A 3.49. So this is 3.49 units on the scale that our graph has here. So if I go 1, 2, 3.5, it's roughly that long, you see. Okay. And so 3.5 units of this scale is about the same as 5 miles on an actual measurement. Okay, so let's come back in here. All right, now let's put up a grid. Okay, I'm going to pull this down so we can see here. I'm going to turn on the grid, and there it is, overlying our image now. All right, so notice that the grid spacing is the same as the scale down here. And so let's use this grid and try and figure out the area of our lake. Okay, so let's count the squares. Okay, so this is 1, and all these little pieces here I'm going to call as 2. They probably add up to about another square. Let's go over here. 3, 4, and then this part in here and here would help fill in this part, so that would be 4 total. Okay, here nearly 5, 6, 7. Some of this water would count to make this one completely 5, so there's 7, and there's not enough to go any further. Let's just call it 7. Here's about 8. Let's call that 9. And let's skip over this and call that 10. Maybe 10 and a half. Let's just go with 10 for now. 11, 12, 13, 14, 15, 16, and 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. I'm going to call that 27, 28, 29, 30. And this one and that one and maybe these make 31, and so 31 or 32. I'm going to go ahead and call this 32 squares, and let's see where that leads us. Okay, let's write down what we have so far. We have our lake. We have a line in here. This line we put in their line segment was 5 miles, and when we measured it in Geogebra, we got 3.49 units. Okay, so 3.49 marks on our scale is equivalent to 5 miles. Okay, now the other thing we got was that there was 32 square units that covered the lake. All right. All right, and so we want to say how many square miles is that. So here we have units and here we have miles. Okay, now these are square units, that's the other thing. So if you have a square unit like this, and you say 3.49 units is equal to 5 miles, you want to know how much is 1 unit. Okay, so if 3.49 units is 5 miles, one way, there's a lot of ways of doing this. You can see, if I divided both sides of this equation by 3.49, I would get 1 unit is 5 over 3.49 miles per unit. Okay, let's just do that. Let's bring up a calculator. So if I have 5 divided by 3.49 equals, that's going to be 1.43 miles per unit. Okay, now does that make sense? Well, if there's 3.49 units here, I would need a little bit more than 1 mile per unit for this to add up to 5 miles. So it looks like we did it the right way. Okay? It's important to check your thinking that way quite frequently. Hey, I make mistakes like that. I get these backwards. Okay? Okay, so if 1 unit here is 1.43 miles, and 1 unit here is 1.43 miles, then what's the area of 1 square unit in square miles? Okay, well, I would have to take 1.43, in fact there's the number, I didn't round it off, let's just use that, and if I say square it, or I multiply it by itself, it means the same thing, so there. So it's going to be 2.05 square miles per square unit. Okay, and let's look at what we have now. We said that the comparison between units and miles, there was 1.43 miles per unit, but there's 2.05 square miles per square unit, and that's just 1.43 squared. I think you can see, since we have to expand the square in 2 directions, 1.43 by 1.43, it's going to be this times this, or this number squared is how many square miles in a square unit. So this is going to be an important number to have in mind here. Okay. Now, how big is our lake? We have 32 square units. Each square unit is 2.05 square miles. So let's figure it out. Bring the calculator back. 32 times 2.05. 32 square units. Each square unit is 2.05 square miles. Multiply. We get 65.6. 65.6. I'm going to abbreviate it the way it's frequently done. Instead of saying SQ miles, we just say miles squared. And there you have it, 65.6 square miles. Now if you remember back to when we just did a simple rectangle, and we estimated the size of a lake by a single rectangle, we get around 72. 9 times 8 is 72. We said pretty much any area between 50 and 100 would probably be in the right ballpark. That gives us some confidence that we did the right steps here. Okay, so here we've measured the area by counting squares. Okay, what I'm going to do in part 3 of this video series is do the same kind of a measurement in some other interesting ways, and so stick with me for that as well. But for now, we have our first claim to be an answer. You might look this up. It's called Mono Lake in California, and you can read up about it. They have an article on Wikipedia, and I'm sure you can find a lot of stuff that's been said about Mono Lake because it really is a lake of interest to a lot of people. Okay, come back for part 3.